This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 2 of graphing the cosecant function, and we're going to graph y equals 2 cosecant of x. And to do that, we're going to look back at the one we did on the first video, which was y equals cosecant of x. So if you recall, what we did is we, on the dotted green line, the dotted line here, we graphed y equals the sine of x, and that's because the cosecant is the same thing as 1 over the sine of x. So we began by graphing the sine of x, and then we took the reciprocals of all the y values. So remember, we got these asymptotes wherever the green went through the x-axis, etc. All right, now the other thing that's very important to note here is in each of these places between the asymptotes, let's say we go in between 0 and pi, the maximum of the sine function, in other words, the maximum y coordinate, is 1, and that's going to be the minimum y coordinate for the cosecant. If you go in between pi and 2 pi over, in between pi and 2 pi, you see this the minimum point of the y equals sine x happens to be the maximum point of y equals cosecant of x. So if you already have y equals cosecant of x drawn, how would you get 2 cosecant of x? Well, your purple shows all your y values, so basically you would multiply all those y values by 2. In other words, this bottom point right here, let me circle it, would start up here if I were going to do y equals 2 cosecant of x. That would be your bottom point, and the whole graph will look almost the same except start going up. So an easy way to do this is still graph y equals 2 sine of x, and then just your bottom point will already be where it is. If you graph the y equals the sine x first, and you take the reciprocals, then you would have to multiply this ordered pair by 2, right? For this y equals 2 cosecant of x to do that. So that's the technique I'm going to use. So first note that y equals 2 cosecant of x. It's the cosecant, right, that is the reciprocal of sine. So this is really 2 over the sine of x. So first of all, we are not doing the reciprocal of 1 over 2 sine x, all right? The 2 still is in the numerator. And that helps us understand why this might work. If we graph y equals 2 sine of x and draw our asymptotes, the maximum and the minimum points just switch. In other words, we're not going to take the reciprocal of 2 and say that it's going to be 1/2. So let's try this. All right, so we want to graph y equals 2 cosecant of x. We're going to use a dotted line to graph y equals 2 sine x. And then first we're going to do our vertical asymptotes. And remember, I use VA for vertical asymptotes. All right, so wherever this crosses the x-axis, we know that the y value, the y coordinate is 0, and the reciprocal of the y coordinate, the reciprocal of 0 is undefined. So we draw in vertical asymptotes right here. And also the actual y-axis is a vertical asymptote. So remember, the curve gets close to that but doesn't ever have any points on it. All right, so now the vertical asymptotes, what are those? And instead of writing the domain, I'm just going to write the equations of the vertical asymptotes. They're vertical lines, so they're the form x equals, and I look and see, where does it go through? It goes through 0, pi, 2 pi. Those are multiples of pi. So I can write that as k pi, where k is an integer. That's the way to write k as an integer without writing that out in words. All right, so this is vertical asymptotes. Now let's graph. Well, remember the maximum points you see for the sine end up being the minimum points for the cosecant. So here's a maximum point here, and then all we have to do is do this little upward thing here. Here's a minimum point, and we go down here. Here's a maximum point, we go up. Here's a minimum point, we go down, and I've graphed 2 cycles, 2 periods, etc. So we have the vertical asymptotes listed. Now, what's the period of this function? It's the same as y equals sine of x. So if you graph y equals 2 sine x, you just say, what's the period of that one? It's going to be the same. And then how about the range? What are the values that the y coordinates take on? Well, it goes down forever. So negative infinity, it goes, the highest in this first part goes up to -2, and it's closed, which means it actually, -2 is one of the numbers in the range, and then it starts again at 2 and goes up forever. And so there we have y equals 2 cosecant of x. The graph is in purple. Make sure you do the solid line for the real graph, that you show the dotted lines, okay, and either state the vertical asymptotes, or you could also just write down, right here what the lines are, but that takes more room. Like this is x equals -pi, right? And you could also show that you know the equation of that line, what the period is, and the range. Now, it's not a bad idea to always just check that one order pair is actually correct. So let's say we want to make sure this really is correct. So what ordered pair is that? Well, this is pi, let's see, pi over 2, 2 pi over 2, 3 pi over 2, right? So that's 3 pi over 2. -2. And so we could do, so this is just a little check. So in other words, y equals 2 cosecant of 3 pi over 2. When you plug that in, you want to make sure you get -2. So what's the cosecant of 3 pi over 2? I always think of the unit circle here. Here's 3 pi over 2, and that ordered pair is 0, -1, right? And how do you get the cosecant? It's the reciprocal of the sine. So the sine is -1, right? That's the y value, so the reciprocal is -1. So this is the same thing as 2 times -1, which actually equals -2. Okay, and that checks. It was supposed to be -2. So in other words, it's always a good idea to make sure that, at least one of those order pairs you drew was correct. It's up to you, of course. I mean, you're taking a test, I would go ahead and make sure that I had one of those points correct. What if we had been asked to do y equals -2 cosecant of x? Can you guess what that's going to look like? There was a minus in front of here. Everything would just start, it would be flipped over the x-axis. So if I were doing -2 cosecant of x, you would graph -2 sine of x. So your dotted line here would be down here, etc. So you should be able to go ahead and work with one that has a negative sign in front of there as well. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.